Hi guys, this video will be about redox, and a redox reaction is one where both oxidation, loss of electrons, and reduction, gain of electrons, happen simultaneously at the same time. And numbers, oxidation numbers or oxidation states, are assigned to atoms of elements taking part in the reaction, and that tells us where electrons have moved from and to. And there's some rules that you'll have to learn in order to be able to do this and answer questions on redox reactions. I've included a general simplified table here with more detail in the description down below, including more information about exceptions. But here, generally speaking, the oxidation number of an element in a compound is often the same as the charge on the ion. Bear in mind there's some cheeky elements. Carbon and chlorine are ones in particular to watch out for, and they can have a range of oxidation numbers. Carbon can be anything from +4 to -4. Chlorine can be anything from +7 to -7. And the way we work out what its oxidation number is by saving that element till last in the compound and working out everything else before that, which we'll see in examples soon. Some example questions here on redox. The first one says, complete sentence 1, the sodium atom becomes a sodium ion by something, an electron. So it's forming a 1+ ion. Electrons are negative. That means we are losing, or we could have written transferring, an electron. The next question, this one says, identify the oxidation number of sulfur in the sulfate ion. Now we have to look at our oxidation rules for oxygen when it's in a compound, and that takes the oxidation number -2. We times that number, the -2, by the number of oxygens we have, 4. -2 times 4 gives -8, and because it's an ion, we need the overall number to add to the charge on the ion. That means sulfur must be positive, and it's got to be a positive number that is 2 numbers smaller than this negative to leave 2 minus overall. So it's +6. Then we've got this one, a reaction between magnesium and sulfuric acid. It's a redox reaction, and it says use redox numbers to identify which element has been oxidized. We've got some elements by themselves in their standard states, and they're given the oxidation number of 0 according to our rules. Hydrogen's nearly always +1 when it's in a compound, and group 2 metals like magnesium are +2. So if an element's been oxidized, then it's increased its oxidation number, it's lost electrons. That would be magnesium. Explanation, Mg has lost 2 electrons. It's gone from 0 to +2. And this one, transition metals have different oxidation states. We've got chromium oxide, and it wants the oxidation number of the chromium. Now, since chromium is a transition metal, it has a variable oxidation state. That means to find its oxidation number, we start with oxygen. There's a rule for oxygen when it's in a compound and bonded to a different element. So oxygen's -2. Just like the example above, we times the oxygens -2 by the number of oxygens we have. -2 times 3 gives us -6 overall for the oxygen. It's a neutral compound, not an ion. That means the oxidation numbers must cancel out to give 0. +6 is what we get overall for the chromium, but we have 2 chromiums. So we divide that +6 by 2 to get the oxidation number of each chromium in this compound.